Let us discuss about proof of the Pythagoras theorem. The word proof is an equivalent word to the word verify or justify, and both words explains about an attempt to make one believe that whatever is said or whatever the fact is existing is actually true. So in this case, we want to make a proof in order to convince people that the Pythagoras theorem is in fact true. Several methods of proving the Pythagoras theorem are there, but here we are just going to discuss one method in which we will be using the similarity theorem to prove the Pythagoras theorem. Consider this triangle. We may call it triangle A, B, C. If you use capital letters to name the vertices of this triangle. And if the vertices are used, capital letters are used, and the sides are named with two capital letters. This would be side AB, BC, AC. But sometimes you may choose not to use two letters, you may choose to use the single letters. But the single letters that are used to name the sides are usually named after the capital letter which has been used to name the opposite angle. So if this is angle A in capital letters, this side will be side A in small letters, and this will be side C in small letters, and this will be side B in a small letter. So the problem here is to prove that AC square plus BC square equals to AB square. That is when we use two letters. But when we use single letters, we will prove that A square plus B square equals to C square. So this is how we go around in proving this. You need to reconstruct this right triangle. It is called A, B, C. And then here you will construct a line which is perpendicular to this line, and this point you may call it BD. We may call it D. So consider triangle BCD and triangle BCA. You consider this small triangle here and this big triangle. We want to show whether the triangles are similar, and later we will show that this triangle is similar to the bigger triangle, and we will use the statements that we will obtain from the proof of this triangle, whether it is similar to this, and the proof that we will obtain from this small triangle and this bigger triangle. We use those statements to prove the Pythagoras theorem. So let us begin with this triangle, that is BCD and BCA. So this is how we do it. The similarity theorem states that if corresponding angles of triangles are similar, then the triangles are, if corresponding angles of triangles are equal, then triangles are similar. And when triangles are similar, the ratio of the corresponding sides are proportional. This means that the ratios that are made by the sides which are corresponding to those triangles will have equal values. So let us see how this works. In this small triangle here, DBC, angle DBC is equal to angle ABC. Why? They are common angles. But angle CDB this angle here in the small triangle will be equal to angle ACB, and this is because they are 90-degree angles. This is the reason. Angle DCB will be equal to angle CAB, and it is because they are third angles. Angle DCB is this angle, and angle CAB is this angle. When we say they are third angles, we mean that when the first two angles are equal, when this angle and this angle, this angle was shared, but this angle and this angle, when the first two angles are equal, the third must be equal. So after that, then you can use these central letters to show this whether the triangles are similar or not. So here you can state triangle BDC is similar to triangle BCA, and the reason is that all angles are equal. All corresponding angles are equal. When all corresponding angles are equal, then the ratios made by the sides will be equal. This is what we call the proportionality needed to show similarity. So take BD and BC. These are letters that are in similar position. BC makes one ratio, DC and CA makes one ratio, and BC and BA makes another ratio. So this is the ratio that is made by those corresponding sides. Now take this ratio and this ratio, because you have BC here and BC here. So if you take the ratio BD over BC equals to BC over BA, and then you do cross multiplication, you will have BC square equals to BD times BA. Call this one statement. This is the first statement that we are going to use later to prove whether the Pythagoras statement is true. Again, consider triangle, this triangle here. Consider this triangle here. This small triangle, call it triangle ADC, and the bigger triangle, which you may call it ACB. This small triangle and the bigger triangle. We are going to again to prove whether they are similar and show the proportionality needed to show similarity of the triangles. Now, in this small triangle here, angle CAD will be equal to angle CAB, and the reason that they are common angles. And angle ADC will be equal to angle ACB, and they are 90 degrees angles. Another angle that will be equal to another will be angle ACD, and this will be equal to angle CAB. ACD will be equal to angle CBA. This angle here, ACD and angle CBA. Okay, so triangle, we use the central letters. Triangle ADC will be similar to triangle ACB, because its corresponding angles are equal. The ratios for proportionality will be AD, AC, which equals to DC, CB, and this will be equals to AC, AB. So you see here you have AC and AC here. So you pick this ratio and this ratio. If you go on, when you have AD over AC equals to AC over AB. If you do cross multiplication, you will have AC square equals to AD times AB. This is the second statement. So we have two statements now. We have this statement here and this statement here. Now take and combine the two statements. Take both the statements and place them together. That is BC square equals to BD times BA. And the second one is AC square equals to AD times AB. Now, if you add these two statements, you'll get BC square plus AC square equals to BD, that is this statement, times BA, then plus this statement AD times AB. And then looking up here, you have BA and AD is one thing, so you just take AB outside the bracket, so you have AB outside the bracket, and here you inside the bracket you will remain with BD plus AD. Then when you look back to this figure here, BD is here and AD is here. So BD and AD makes AB. So this is the same as AB times AB. And this equals to AB square. So you have what? You have BC square plus AC square equals to AB square. And this is what we were actually proving. Remember here, what we were proving is this. We had to prove that AC square plus BC square equals to AB square. And when you look back here, you will see that if you rearrange this, it is the same as AC square plus BC square equals to AB square. And this is actually proved. And or you can say, if you use single letters coming back here, AC, this one is B square. And BC is A square. This equals AB, which is C square. So it is the same statement actually we were proving here. You can rearrange this. You can write here A square plus B square equals to C square. And this is actually proved. So the Pythagoras theorem, which states that the square of the hypotenuse of the sum of squares of the two adjacent sides equals to the square of the hypotenuse side, is now proved. And it is proved when two letters are used to name the sides or when single letters are used to name the sides. I hope this video will help you to understand